Assalamualaikum. Today we will present about our processor named Fusion X14 and we will compare it with Intel Core i5 1135G7. We are from group 11 and I will introduce you guys to our members. First we have Nurin Najwa, Fatin Nabila, me, Siti Zulaika, and lastly is Alia Sofia. Okay, why we choose Fusion X14 name? Because fusion is the act of fusing, which is the act of combine things to form a new thing. So with the meaning of fusion, we try to create or design a new processor that can do a lot of things with a great performance. Means combine that we can play games and edit video in one time. The word X in the Fusion X14 means extra, but without E. That means it can do another work also, just not for gaming and content creation. Okay. So why is our processor is the best processor? Because it have a 10 cores and 20 threads. With these cores and threads, it can handle multitasking with a great performance. It also have a clock speed 2.8 gigahertz as the base and 4.7 gigahertz for a boost. Then our TDP is a 65 watt that is very efficient for its performance class. Next, I will pass it to the Sophie.
Okay, next, we will talk about trade-offs in Fusion X14. Trade-off is a situation in which the achievement of one quality or aspect involves the sacrifice of another. So, in this case, we have prioritized some trade-offs. And in terms of instruction set design, we use 64 x86 64 architecture, and we added extended registers. We use 64-bit address, RIP relative addressing, and we also apply symmetric multiprocessing. For pipelining, we improve the clock speed and we use higher instruction throughput. Other than that, for the memory system organization, we make sure that the memory hierarchy is advanced. Next, I will show you how to apply the CPI and Amdahl's law for this processor. As we can see here, this is the overall CPI of Fusion X and Intel Core i5. First, we have to assume the instructions load and CPI. By using this equation, we achieve 2.05 CPI for Fusion X14 and 2.20 CPI for Intel Core i5, on which the lower amount shows that it is much more efficient than Intel Core i5. Next, for this potential speed up, we assume that the workload that can be parallelized is 90%. And then by using this equation, which is the Amdahl's law, we get the number of 7.27 speed up for Fusion X14 and 3.08 speed up for Intel Core i5, on which the Fusion X14 is much more faster than Intel Core i5. Okay, next we will get back to the bottleneck. Okay, so here is some bottlenecks in Fusion X14, which is thermal throttling, intercore communication, and memory bandwidth. In order to overcome this bottleneck, we use effective cooling methods and we use much better thermal management for thermal throttling. As for memory bandwidth, we have much greater space for memory bandwidth, and then we also prioritize our NUMA. Next, for the intercore communication, we use much more efficient communication protocols, and we make sure that the workloads is balanced between between all the instructions. That's all from us. Thank you for listening.